Okay, so in this video we're going to look at factoring out the GCF, or factoring out the greatest common factor. To do this, I'm going to start by looking at my problem. I have 4x to the fourth y plus 8x cubed y. So the first thing I'm going to do is I'm going to look at each of my two terms individually, this being term 1 and this being term 2, and I am going to try to write those as their prime factorizations, and this is how you do that. I'm going to start just by going off to the side here and writing 4x to the fourth y is equal to something, we'll come back to that in a second, and 8x cubed y equals something. So what I'm going to do is I'm going to start with 4x to the fourth y, and I'm going to see how far I can break that down. I want each piece of this term, so the 4, the x, and the y, to be written in as simple a form as possible. So for example, 4 can also be written as 2 times 2. 2 is a prime number, so that's ideally what I want, is I want to write that as a prime number. X to the fourth, well, that's just x times x times x times x. And y, well, that's just y, or y to the first. So I've now written 4x to the fourth y in its prime factorization. And I can do the same thing with 8x cubed y. So 8 is the same as 4 times 2, but 4 is not prime. So I could actually write that as 2 times 2 times 2, because 2 times 2 gives me 4, times 2 gives me 8. X cubed, again, is just x times x times x, and I still have this y in the end. Okay, so now that both terms are written in their prime factorizations, I'm going to go through both of these, one term at a time, and see what they both have in common. So for example, I'll start with my 2's. What is the greatest amount of 2's that each term has? Well, this first term has 2 2's, and the second term has 3 2's. So the greatest amount that they both have is 2. So there's 2 2's. Same thing for the x's. There's 4 here, there's 3 here. So the most they both have is 3. And y, well, they both have 1 y. So now I can say my GCF is everything I just boxed in. So my GCF is 2 times 2, because I took 2 2's out of each. I took 3 x's, and I took 1 y. So my GCF is 2 times 2 times x times x times x times y. But I can simplify that. Since I found my GCF, I'm no longer concerned with this form. I don't need to keep it in that form. So I'm just going to simplify it. 2 times 2 is 4. X times x times x is x cubed. And I still have my y. So my GCF is 4x cubed y. You might think we're done, but not quite yet. Usually when you give your GCF, you want to write it with respect to where you started. So where we started with our 4x to the fourth y plus 8x cubed y. And how I do that is I start by writing my GCF, and then I'm going to put an open set of parentheses. And I'm going to say 4x cubed y times what gives me my first term, plus 4x cubed y times what gives me my second term. So you could do that through multiplication and just think, okay, well, 4x cubed y times x would give me this, because x cubed times x would give me x to the fourth. Or you could also just look at our prime factorizations. All you need to put in here for each term is whatever we left over. So for 4x to the fourth y, we left this x out. Hey, what do you know? It's just x. Which means for our second term, we have an addition symbol here, so I'm going to carry that down. What about 4x cubed y and 8x cubed y? What did I leave over? Oh, I left a 2. 4 times 2 is 8, 8x cubed y. So the way I'm going to give my final solution is just like that. And that is how you factor out a GCF. Alright, so now we're going to take a look at another example of factoring out the GCF, or the greatest common factor, but this time we're going to look at it when it's a little bit longer. So in this case we have 3 terms, this is a trinomial, and in this case our trinomial has 2 different variables, x and y. So we're going to follow the same method. So the first thing I'm going to do is I'm going to write out each one of my 3 terms off to the side here. So my first term is 3x to the fourth y to the third. Second term is 12x cubed y, and my last term is 18x squared y squared. Well, if I'm going to write out the prime factorization of 3x to the fourth y cubed, 3 is already prime, X to the fourth is just x times itself 4 times, so I have times x, times x, times x, times x. Y to the cubed, same idea, that'd be y times y times y. Next I'll look down at 12x cubed y. Well, 12 is the same as 4 times 3. 4 is not prime, so I could say that 4 is actually 2 times 2. So I can rewrite 12 as 2 times 2, which is 4, times 3 will give me 12. And then I'll have my x times x times x times y. And then lastly I have 18x squared y squared. Well, 18 is 9 times 2. 9 is the same as 3 times 3. So I can rewrite 18 as 3 times 3, which is 9, times 2 gives me 18. And then I have my x squared, and I have my y squared. Alright, so I have the prime factorizations of my 3 terms. Now I'm just going to take a look and see what they all have in common. Well, first it looks like they each have at least 1 3. What about the x's? I have 3 here, I'm sorry, 4 here, I have 3 here, and I have 2 here. So it looks like each one has at least 2 x's. And it looks like each term has at least 1 y. So I can come down here and say that my GCF is equal to 3 times x times y. And I can just rewrite that and simplify it. So this would be 3, x times x is x squared, y. So that's my GCF. Now we're almost done. Just like the last one, we want to make sure that when we write our final or present our final solution, we do that with respect to where we started. So just like before, we're going to start by writing out our GCF, which we just said was 3x squared y. Open up these parentheses. What's left over from our first term? What did we not circle? Well, it looks like we didn't circle, or box in this case. We didn't box x squared y squared. So my first term inside the parentheses will be x squared y squared. I have an addition symbol in front of my next term, so I'll carry that down. What's left over? 2 times 2, that makes 4. X, and nothing else, so just 4x. Cool. And then lastly, our final term has a subtraction or a minus symbol in front, so I'll just carry that down here. So I have minus. And we have 3 times 2 is 6 times y. So 4x minus 6y. And now just to double check this, if I take 3x squared y times x squared y squared, this would become 3x to the 4th y cubed, exactly what we want. For our second term, 3x squared y times 4x, well 3 times 4 is 12. X squared times x gives us x cubed. So that's good. And lastly, if we take our GCF multiplied by negative 6y, 3 times negative 6 is negative 18, x squared, y times y is y squared. So that checks out. And we're done.